Okay. In the plasma protein, circulated within the plasma in blood, we have another kind of protein which is called complement. Complement is an antimicrobial protein that's in circulation in the blood plasma in an inactive form. And it's going to become activated and become antimicrobial when it is cut into pieces. So when we talk about complement, we're going to talk about how complement is this big protein, and it gets cut into these pieces, and the piece we're going to focus on is the one that's called C3. Now, what causes complement to be activated? Now, what you're going to do, you're going to look at the slide, this slide right here. It's a complicated slide, and we're going to be talking about the top part of it right now. And so we have three different pathways that are pointing to the center of the slide. So we're going to look at the three ways that we get C3. So what causes this inactive complement protein to become chopped up into a piece, the C3 fragment that's going to play such an important role in immunity? And so we have the classic way that this happens. What happens is when an antibody binds to a pathogen, it exposes a enzyme on the side of the antibody, which catalyzes the complement. And so what that means, it cuts it into these fragments. And so that's the original way of getting C3. The classical way of getting C3 is through this. Now C3 then gets broken into C3A and C3B. So if you look at your pathway, it's going to end up being broken into even two more pieces. So C3A and C3B. Well, it ends up that some of that C3B is going to bind to the pathogen on its own. So we had said you have to have the first thing first. You have to have the classic pathway where the antigens and antibodies are there, and you've created these C3 fragments, and then they get broken down into the C3A and C3B, cut in half, basically. Well, one of these, the C3B, will just bind to a pathogen anyway, and that will cause more complement. When C3B binds to a pathogen, it causes the production of more C3. And so that is called the antibody-independent pathway, or the alternate pathway. So we have the classic pathway of producing the C3 fragment, which is done just through antibody binding to a pathogen. And then, as a result of the C3 that's floating around, that gets further broken down into C3B, some of that C3B is going to bind to a pathogen, and it produces more C3. That is that alternate pathway. We then have the lectin pathway. And in the lectin pathway, there are carbohydrates. Lectins are carbohydrates. I always have to look at this one. The lectin pathway, just the carbohydrates on the surface of a pathogen are also going to produce this C3 fragment, which breaks into C3A and C3B. And now, what do they do? And you might be saying at this point, who cares? C3A, C3B, what do they do? Next, I'm going to stop here and put on the board the 5 different ways that they assist in killing pathogens. So the top half of this slide, we talked about how we get C3A and C3B. The bottom half is the next thing we're going to talk about, and we're going to talk about what do these fragments do.